So here, 6.2, we're going to look at slopes of parallel and perpendicular lines. So we're going to need to remember from yesterday that slope is equal to small m. That's the variable that we use for slope. Is equal to rise over run, which is equal to y2 minus y1 over x2 minus x1. And that comes from two coordinate points. First point and a second point. And that's where the 1 and 2's come from. Now this little part over here, this x2 cannot equal x1 thing, we have to kind of say that because we can't have this denominator end up equaling 0. Because we can't divide by 0, we get what's called undefined. So if x2 actually equaled x1, then x2 minus x1 would equal 0, and we can't divide by 0, we get an empty set. So we have to give you this little extra rule. I'm not going to expect that you remember that extra rule, just know that you can't divide by 0. It's just one of those things. Okay? So, quick investigation. Draw the following two line segments on a piece of grid paper provided below. A, which has coordinates 2, 3. B, which is 6, 5. C, negative 1, 4. D, 3, 6. What do the two lines have in common? Determine the slopes of both lines. So if we plot AB, 2, 3, and 6, 5. 2, 3, here's A, and 6, 5, there's B. There's our line segment. And then we plot CD, which is negative 1, 4, and D, which is 3, 6. And there's our line segment. What do those two line segments have in common? Determine the slopes between the two lines. So if we very quickly look at this and we calculate our slope, which is rise over run, 2 over 4, rise over run, 2 over 4. We know that, or we can very quickly say by looking at that the slopes of the two lines are 2 over 4. To use our formula, we would say, well, if we're looking for the slope of AB, m is equal to y2 minus y1 over x2 minus x1, which is equal to 5 minus 3 over 6 minus 2, which is equal to 2 over 4, which reduces to 1/2. Similar calculation for CD. Slope is equal to y2 minus y1 over x2 minus x1, which is equal to 6 minus 4 over 3 minus a negative 1. Minus a minus is a plus, so this is going to be 2 over 4. Excuse me. This reduces to 1/2. So you can see that both of these slopes are the same. This tells us that these two lines are parallel. So if two line segments have the same slope, they're parallel. And one way we can write that is by saying AB, line segment AB, is parallel to line segment CD. And then those rules are just listed a little bit below here. If the slopes of two line segments are parallel or equal, the line segments are parallel. Or vice versa, if the two non-vertical line segments are parallel, then their slopes are equal. Two little rules to remember. I'll come back with an example in a second.